Alright, Chem students, today we're going to continue talking about the periodic table. You need your periodic table notes on page 2 and a periodic table and something to write with. Now, a group, which is also known as a family, is a column of elements on the periodic table. Elements in a group have similar chemical and physical properties and are designated by numbers 1 through 18. A period on the periodic table is one of the horizontal rows. They are designated by numbers 1 through 7, which represents the number of energy levels. Going across a period, each element has one more proton and is less metallic than its predecessor. Now, the periodic table is also separated into metals and nonmetals. A zigzag line will separate the metals on the left from the nonmetals on the right. Now, the one exception is hydrogen. Hydrogen technically is on the left, but it should be over on the nonmetal side. The next thing we need to talk about are the properties of metals versus nonmetals. Now, valence electrons. Metals generally have 1 to 3 valence electrons, whereas nonmetals have 4 through 8. Now, oxidation number, metals will always lose an electron to become cations, and nonmetals will gain an electron or electrons to become anions. Chemical properties of metals, they will form basic oxides. Nonmetals will form acidic oxides. Another property that we look at is electronegativity. Metals have low electronegativity, whereas nonmetals have very high electronegativity. Now, in terms of redox reactions, metals are called reducing agents, and nonmetals are good oxidizing agents. Now, conductivity. Conductivity is the ability for electrons to flow. Metals are very good at letting electrons flow through them. That's why we use them for all our wiring and stuff. Nonmetals, however, are poor conductors of electricity. Now, insulation prevents flow of electrons, so the opposite is going to be true. Metals are very poor at insulation. Nonmetals are very good insulators. Ductility. Ductility is the ability to pull something into a wire. So if you know anything about metals, most wires are made of metal, so metals are extremely ductile. Nonmetals are not ductile. Malleability means ability to hammer into a sheet or to mold it. Metals, very good at being molded into different things. We can hammer them into whatever shape we want, so they are malleable. Nonmetals are very brittle when they're solids. In terms of melting and boiling points, metals have a very high melting or boiling point. It takes a lot of heat to get them to melt. Whereas nonmetals, it's very low. In fact, a lot of them are gases. Now, luster means reflectiveness or shiny. Like metals are kind of shiny. They are very lustrous. Nonmetals, there is no luster. There is no shine. And lastly, our state of matter. Most metals are solids. Two exceptions, mercury and gallium. Nonmetals, however, are solids, liquids, and gases. If you need to, take a minute, pause the video, and make sure you got all of this chart filled out. Okay, the first group we're going to talk about is the alkali metals. Alkali metals have one valence electron, and they will lose that one electron to form the +1 cation. Now, in terms of chemical properties, they need to be stored under oil because they are extremely explosive when exposed to air. These are the most reactive metals, and they will always be in compounds. The physical property for alkali metals is that they are soft, silvery metals. We can use them in soaps, lights, batteries, nuclear reactors, electrolytes in living things. Hydrogen is an exception and is a non-metal. And again, this is group 1. Now, group 2 has the alkaline earth metals. Okay, now group 2 is the alkaline earth metals. It has 2 valence electrons. It will lose those 2 electrons to form the +2 cation. Now the chemical property for the alkaline earth metals is that they are reactive, but less so than the alkali metals. In terms of physical properties, they are harder and more dense than the alkalis. We will often use these in fireworks, alloys for aircraft, some gemstones, marble, granite. Calcium is also needed in the body for strong bones and teeth. Okay, our next group, this is in the middle, 3 through 12, also known as the transition metals. These are multivalent, meaning they have variable charges or oxidation states. Chemical property for the transition metals is they are less reactive than alkali and alkaline earth metals, and many are found alone in nature. Physical property, they are hard, they are high density, and they are usually silver in color. Mercury is the only liquid metal at room temperature. Now the uses for the transition metals: steel, coins, electrical wiring, plumbing, jewelry, construction. A lot of the day-to-day stuff that you're used to, working with when we talk about metals. Now our inner transition metals are down at the bottom. That's the F block. These are the lanthanides, and the lanthanides are silver. They have a high melting point, and they are very valuable metals. We use them in the glass industry as well as in cell phones. The actinides, the one right below it, they are extremely radioactive. We will use them for nuclear fuel, nuclear medicine, or research. Okay, that brings us to the post-transition metals. We're also calling these the poor metals. Now the physical property for the post-transition metals is they have a low melting point, and they are very soft metals. Aluminum and tin we can use for cooking and food storage. Gallium and indium are valuable in electronic parts, non-mercury thermometers, and glass insulators. Thallium is a ridiculously awful poison, so that's a bad use, but it's still a use. And then lead, radiation insulator, because it's very dense, it can block radiation. Now, metalloids. Metalloids are this area along the zigzag. They have properties of metals and nonmetals. Like I said, they're found on either side, except for aluminum. Aluminum is on that line, but it's not one of them. Now their physical property is they are mostly brittle, but they are semiconductors. That means they can conduct electricity, but not heat. They can only conduct the electricity. In terms of uses, being a semiconductor is very valuable, so we use these metalloids for computer chips, such as silicon, and eyewash, which is what boron is used for. Okay, and that brings us to our nonmetals. Nonmetals are elements to the right of the zigzag line, and hydrogen. The physical property of nonmetals is they are poor electrical conductors. They are very good insulators. They are non-ductile. They exist in various phases of matter, meaning you might find them as a solid, liquid, or gas. And in terms of uses, many are needed for your health. Now, one of the last groups we're going to talk about are the halogens. They are group 17. The halogens have 7 valence electrons. They will gain 1 electron to form the -1 cation. The chemical property of the halogens is they are the most reactive group of nonmetals. They will burn flesh, they will burn everything they touch almost. Physical properties: strong, unpleasant odor. They do not dissolve in water. Fluorine and chlorine are yellow-green gases, and if you know anything about history, chlorine gas has been used in wars and outlawed for many reasons. Bromine is a dark red liquid. Iodine is a purple-black crystalline solid. Now, in terms of uses, we can use small amounts of radioactive iodine to treat cancer, and we can also use this stuff to help bones, teeth, DNA, medicines, Xerox copying, bleach, and to make antiseptics. Now our last group is group 18. That is the noble gases. Noble gases have 8 valence electrons. For this reason, they do not lose or gain electrons. They're completely content with the full outer shell. They don't have a desire to interact with any other elements. Chemical property, no chemical reactivity. Like I said, they don't have a reason to react with anything. Physical property, all of them are gases. Now, even though they don't react with anything, we can still use them. We can use them in hot air balloons or to make glowing lights like neon signs. Alright, that's it for today's video, Chem students. We'll see you on the next one.